Welcome back to the Afterword, a conversation about the future of words. We are so glad to have Dr. Tiffaney and Dr. Brenton DeBoef here with us to continue our conversation about the background stories we tell and the words we use regarding vaccination. In the first half of the episode, we covered the story of vaccines in general. Now we want to dive a little more deeply into the coronavirus vaccine that's on everyone's mind. One vocabulary word that Amy didn't ask you to define at the beginning of the last episode was the word unprecedented, probably because she's stricken that word from use. We've heard so many times over the last 12 months, we live in unprecedented times. People say that a lot. But in fact, globally, or at least large-scale pandemics are nothing novel. So in what ways has the coronavirus pandemic been like the pandemics we've seen in the past? And in what ways is it different?
So, yeah, as you've mentioned, we've seen a number of pandemics throughout history, previous influenza pandemics, and even, yes, previous coronavirus pandemics. You've got SARS and MERS, which is the Middle East respiratory syndrome. SARS is the severe acute respiratory syndrome. The mortality rates have been pretty high on those, but fortunately, they haven't been as transmissible as what we're seeing right now. But probably this COVID-19 that we have, it most compares to, or at least I've heard it most compared to the Spanish flu pandemic that plagued the planet about 100 years ago from 1918 to 1920. Over 500 million people were infected. That's roughly 2/3 of the world's population at that time, and 50 million deaths occurred. In fact, my great-grandmother actually died in the Spanish flu pandemic and left behind 4 little children. So the devastation of pandemics is nothing new to us. Fortunately, we haven't had as many deaths yet from COVID-19 as the Spanish flu. I'm sure part of that's attributed to better health technology to help people from a medical perspective survive. We also have internet that was able to transmit the genetic code for the COVID-19 virus within just weeks after identifying the virus. So scientists were jumping on it immediately, preparing to make vaccine for it. There are numerous vaccine trials out there going on right now. But similar to all pandemics, they're accompanied by a large degree of fear, anxiety, uncertainty. And of course, we would be remiss if we didn't say economic disaster. I mean, that happens every time. And, you know, we are definitely feeling the economic impacts of COVID-19 virus, certainly at this time. But our ability to network, communicate information, I mean, I'll be honest with you, I love reading and learning. It's probably why I'm in academia and teaching, but it's almost overwhelming how much information comes out about COVID-19, the virus, the vaccine, every day. I mean, my inbox is always full of new information, and I try my best to keep up with it, but it's just happening at lightning speed. And as we mentioned, the economic impact is huge. I think it'll be some time to come before we even know how much that has impacted us. I mean, people losing their jobs as a result of this. But we also have social media that's playing a huge role in helping people keep better informed and understanding what they can do. We have better methods for getting the vaccine out, although we're seeing some shortcomings in the systems that we thought would work. They're not quite getting the vaccines out to everybody, but things have been done much quicker. I mean, even looking at creating the vaccines, that's happened at a much faster pace than anyone would have ever dreamed could be possible. So, you know, a lot of similarities, but a lot of differences in there as well.
Yeah, I guess I agree with you that there have been, pandemics are nothing new. I mean, we've even heard, skeptics point to, but like this idea that Bill Gates was kind of talking about how this was the next big thing to hit. And it's not because he had some, predictive ability. It's because we knew that this was inevitable. These things happen. What is unique about this one, from my perspective as a researcher, is just the massive scientific response to this. Right now, I'm pretty sure there's more COVID research going on than there is cancer research going on, at least in academic laboratories. I mean, like this is bigger than the Manhattan Project, right? For this kind of like instant collaboration of scientists on one topic. It's really quite impressive, from my perspective. And that's because there's just such a pronounced need. I mean, we're all living through it right now. I mean, we're talking remotely, right, because of it. And yeah, Tiffany and I are teaching classes and holding meetings remotely all day long. I'm guessing Holland and Amy are too, right? That's just kind of the new normal. And I mean, I think everybody is really excited about getting back to the old normal.
Well, I'm not 100% sure about that, but that's a different topic. I think we're going to see some things change maybe permanently. Not everything, but some things.
Oh, we've been talking about that at the university a lot. I don't know if you have, Tiffany, but just about what we're taking away from this and how things are going to look. I think a lot of people are going back to, I mean, we're a residential campus, so a lot of people are excited about having students back on campus and, dorms full and stuff and intramural sports and the whole deal. But I mean, I think you're right. We have learned a lot. We've actually learned that it's actually possible to do a lot of this stuff remotely that we never knew before.
Right.
Exactly.
We call those coronatudes, blessings from Corona, a gratitude. But, you've mentioned a few things that, both of you have just talked about this, but Brenton, you talked about this kind of the difference being this collaboration between researchers, and something though that a lot of people have remarked on and maybe created some of the false information and the rumors is the speed with which the vaccine has been developed. So you touched on it a little bit, but let's dig a little bit farther into this. How were researchers able to develop this so fast? And can these methods be trusted and safe?
So I'm going to try to nerd out a little bit, but keep it, not too nerdy. So vaccine research was really poised for a transformation for a long time. I mean, I think a lot of people knew this. And so even it's still the way the flu vaccine is made right now. I don't know if everyone realizes this. They are made in eggs, literal eggs. There are chicken farms all around America that produce the eggs that vaccines are made in. If you want to hear just a little bit more, you want to dig a little deeper, I'll try to whet your appetite. There's a great Radiolab episode, if you're into Radiolab for podcasts, can't recommend it enough, called The Great Vaccinator, which really describes how the measles vaccine, or not the mumps vaccine was made this way. So what you do is you take actually live virus and you inject it into eggs and you wait to see what happens, basically. And you just keep trying, and eventually you get, some egg that isn't too damaged by the virus. And the assumption is that you can then use that to make a vaccine. So I kid you not, vaccines, the majority of vaccines are literally made in chicken eggs, or that's kind of the classic way to make a vaccine. And so, I mean, it's really quite antiquated technology. By the way, that's part of the reason you see a lot of allergic responses, or a lot of the allergic responses that you see are actually from the egg. You actually see that, people ask you, are you allergic to eggs when you're taking vaccine? That's why. It's because this thing was made in an egg. And so, really, quite frankly, a lot of biomedical science has advanced and kind of left vaccine development in the dust. And so we were poised for this. And so what we just have is kind of this confluence, sorry, got the wrong word there, of medical research basically lining up with societal need. And so there were companies out there like Moderna and BioNTech that had basically had ideas about better ways to make vaccines. I'm going to try to just nerd it real quick here, okay? So the way these vaccines are different is that they do not contain virus, right? So these old-fashioned vaccines, like I said, the ones that are made in eggs, they contain a weakened or a dead version of the virus, or, they contain some version of the actual virus. What these new wave vaccines contain is just the genetic code for one protein of the virus. So if you've seen, coronavirus, or, it's the spiky ball or whatever, right? And so, okay, I'm such a nerd. I 3D printed a copy of the spiky ball, right? I guess I didn't bring it here because it's a podcast. If we were on YouTube or something like that, I'd be holding it up right now. But
Brenton,
right?
I've seen people crochet that thing. It's got way more track record than anybody should ever have given it.
You're right about that. So what we were able to do, researchers very early on were able to decode the genetics of the virus itself, right? The virus is made of DNA, just like you and I have DNA in us. And well, in this case, it's RNA, but they could decode the virus itself. And what we could do is we could take that little code, and that code and so what they do is you chop up the code of the virus, and you just give the patient one part of the code that makes one protein in the virus, and that's all we need in order to teach your body how to fight the disease. And so that one code or that one protein they make is the little spikes on the virus. So those little spikes, they don't make you sick at all. The bad stuff's on the inside of the ball. But by just giving a person just the code to make those spikes, that's all you need to do. It's a totally different way of making it. It's so much faster. And it is. And as I think we're going to see, it's going to be way more effective. I think we're already seeing the data showing these new wave vaccines have less side effects than old vaccines. They don't have to have kind of crazy preservatives in them and stuff because they're not from eggs. All it is just a little piece of genetic code, which is totally natural. Like your body knows how to handle it.
Amazing. Tiffaney, tag in.
Yeah, and this technology is not new. They've been using this technology for over 10 years now, and maybe even longer. It's been in research process, I think, for closer to 30 years, but successfully, working with it over 10 years. And there's some anti-HIV drugs in process. I think some anti-cancer drugs in process using this technology. But because you're not using this infectious element, it's non-infectious, you can shorten the manufacturer times significantly for this. But one thing that I want to be clear about and make sure that everyone understands is that the same rigorous standards that all vaccines have to go through are being followed.
That's right.
And in this case, so the red tape was removed for a lot of this because it was warp speed. It was trying to get the vaccine there as fast as possible. And so some of the things that would have normally held it down, like wait times in between when a trial was finished before they could get the go-ahead to go ahead, everything was expedited. But in my mind, I view it that so many eyes have been on this vaccine data, probably more than any other vaccines that have come out in our modern history. And the data has been so evaluated that maybe we should take some comfort in that, in knowing that, it's been looked at from every which angle. And I think, I've heard rumor that this vaccine can get into people's DNA and cause problems from that perspective. But I think it's important to understand that this messenger RNA technology, it never enters our cells. So it's not affecting our genetic material. But that's just a piece of misinformation that I know is circulated out there that I want to make sure that people know it's not going to modify your genetic makeup.
And there's no chips in those things either, huh?
No.
Yeah, I don't say that. That would be the easiest. When you hear someone say that, not that I'm an expert in how to, defeat, misinformation, but just, that would be a real easy thing to test. All you need is to get a vial of the vaccine and put it under a microscope and see if a chip is there, right? Like if there was a chip in there, someone would have done that by now. Right? That's just not how this works. Plus, if there was some chip that would make you a cyborg, right? Like it'd have to have a battery, it'd have to have an antenna, it'd have to, that's not.
That's tough. Not going to happen. Wow. This was so good. I'm so glad that you both brought two different perspectives. And again, agreeing on the rigorous science that has gone into it. That's fantastic. Thank you.
Yeah. I just want to point out, it would have been unethical for medical scientists to have slow walked this, right? There's literally people dying. There's right now in the US, or at least during January, there's 3,000 people dying a day of COVID. If we would, just wait and kind of take our time and, fiddle around, that would have been completely unethical. This had to be fast tracked.
Great point.
I'm thinking about it. I was on the phone this morning, spent over an hour with a colleague of mine in India, and we talked a little bit about how different countries are responding and how they're able to respond to the pandemic. And I know I've been seeing in the news that wealthy countries could get enough vaccines to reach herd immunity by the end of 2021. But poor and middle income countries, on the other hand, could be living with this pandemic for up to the next 7 years. Could you help us understand why this disparity exists and what, if anything, can be done about it?
Well, I suspect that the mighty dollar plays a role in it. I mean, the companies that are going to the expense to make the vaccines obviously are selling the vaccine. They're not just giving it away. And so the countries that can pay for it, that have the resources, are going to be the ones that get it. And the other countries are going to have to wait, probably before more and more vaccines come on the market and it becomes more competitive to be able to get a vaccine at a lower rate. In an ideal world, we'd be able to get these vaccines and just ship them everywhere. And to give them to anyone who needs it. But, even in our country right now, where we have plenty of resources, we have a federal government that paid for the vaccine for us, we're still struggling to get enough vaccine for everyone, and then struggling to get it out to everybody that needs it. We have, within our own country, we have areas that are called vaccine deserts, which are just lacking in the vaccine. But in some countries, as you mentioned, the poor and middle income countries, the whole country is essentially a vaccine desert where they can't get it. But if I may, while we're talking about disparities, disparities exist within our own country and even within different ethnic groups. We know that the COVID-19 virus, that it impacts people of color disproportionately. But here's the thing that I want to make sure everyone understands, that vaccines have the potential to be an equalizer of health disparities, especially around infectious diseases. And so I hope that the World Health Organization is really looking at these disadvantaged countries and making a plan to get the vaccine into their hands.
Yeah, this is just a sad reality. And it's actually going to be exacerbated right now because it looks like the AstraZeneca vaccine is not as effective, and that's the cheapest of all of them. So the AZ vaccine costs about $3 a dose, whereas the Pfizer and Moderna ones are coming in at, I think, $15 a dose. That's partly because of the way they're produced. So the Pfizer Moderna ones, I guess I keep lumping them together. Obviously, they're two different companies, but they essentially invented the same thing. Just simultaneously used basically the same technology to invent the same type of thing. So I just lump them together. Those are, the process of actually making the vaccine is quite difficult. And the process, like I was saying earlier, of how to identify what vaccine to make is much faster and better now, but the actual manufacturing of it is quite difficult. The RNA that is inside these is a notoriously unstable molecule, and so it falls apart real easily. That's why they have to be kept so cold and stuff. So it's just inherently difficult to do, and it's going to be inherently expensive. That's why the real hope was the AstraZeneca vaccine, quite frankly. And now, we've been seeing some sad news over the last couple of days, especially against the South African variant. It looks like it's not as effective, and so that's actually going to delay the situation in the developing world even more. It's just very sad.
Mm-hmm. Well, with all of the collaboration, the eyes on the data, the research, again, one more problem to overcome. And it sounds like you both are bringing up some excellent points. And Brenton, I'm glad you brought up the idea of the reason why it has to stay so cold. I think a lot of people were wondering about that. Why does it always have to be so cold in a refrigerator? So I really appreciate the fact that you brought that in to the conversation. But Tiffaney, you talked a little bit about this in our first episode about, we're only a plane ride away from a disease. And in some countries where vaccination of children has not been routinely carried out due to COVID restrictions or war, we've seen this especially in areas like Syria. We've seen an outbreak of measles and things like that. So you shared a little bit more, but let's go a little bit farther into the continual need for protocols and effective prevention, because just because we work through a vaccine protocol for COVID-19 this year doesn't mean we're done, right?
Right. Yeah, we're definitely not. And with children and their vaccinations, we've actually seen a decline in children's vaccination rates with COVID. Largely, we think it's because, parents haven't wanted to take their children into the doctor's offices because of the COVID-19 virus circulating. And so some states have come out with protocols that have allowed pharmacists and community pharmacies to start giving some of these childhood vaccines that we haven't been able to give before. In fact, South Carolina just updated their protocol that, we can give influenza vaccine to children 3 and up without a prescription and just by the pharmacist authority. And then we can give all the other childhood vaccines via prescription. So a child wouldn't even have to go to a physician's office to get them. They could get them at a pharmacy, which we know is oftentimes much more accessible to people. So those kinds of protocols need to continue in order to make sure that we are doing our best to make sure that every segment of the population is able to get the vaccines that are recommended for them in an easy way to make it very accessible. And that will be key to helping us have that preventative health that we really strive for.
Excellent. What about you, Brenton?
So, I think there have been cases of smallpox. One that we talked about in the last segment is a case where we have completely eradicated the disease. But even polio, a disease that we don't have over here in the U.S., there still is cases of polio in the country. It has not been completely eradicated. And so until you get to that point of eradication, we're going to be living with these things, right? Now, in another case, of course, the vaccine that we're most comfortable with, flu, is, what we're dealing with there is a virus that mutates pretty well. And there's kind of these different strains of flu. And so we have to get a different vaccine each year. We don't know how this is going to play out with COVID, although we are seeing mutations, right? Like that's a thing. And so this could be just a new disease that we have to be vaccinated for on a regular basis in order to keep the population healthy. I'm just going to go back to the new wave vaccines, though, the ones that we see with the mRNA based ones, the Pfizer and the Moderna ones. It's going to be very easy to adapt those, or much easier to adapt to make new vaccines to track with new variants. And so I think the technology is going to be able to keep up. But the way to eradicate is not, the technology's there. It's this kind of thing only works if everyone does it. And so the way to eradication is herd immunity.
So the good news and the bad news.
Mm-hmm.
Yeah. Okay.
We have a signature question that we end every conversation with, and that is, what's a metaphor to help us better understand this topic? So, Tiffaney, what's a metaphor to help us understand vaccines or vaccination?
So I guess this is sort of a metaphor. I'm going to just tell you what I tell my students in class when I'm teaching. And I tell them, let's say I put on this table a steering wheel, a tire, and a gear shift. What would you tell me that this belongs to? And they would say, a car. And I'll say, okay, so using only these items, could I drive this car? And they would look at me like, you're crazy. No, you can't. You would need much more to drive a car. Well, that's sort of like what we're doing with vaccines. As Brenton mentioned, you've got that spike protein that we're using to create an immune response. You're taking, one part of the virus and you're making the body recognize it as foreign so it can tag it and get rid of it as soon as it tries to get in the body to create disease. So I guess, is that a metaphor like you were looking for? Is that what you were hoping for?
We get all kinds of interesting answers, but really what we're looking for is a word picture. And I think that was a powerful word picture.
Yeah, absolutely. Okay. I mean, as you're saying that, I'm literally picturing the parts on a table of a car and going, yeah, hilarious. It's part of the story. Excellent.
All right. For me, I guess the metaphor that I use when I'm trying to explain at least some of the science behind the vaccines, especially these new ones, the Pfizer, BioNTech, and Moderna ones, I always use the idea of a printer. Like, you can complain about the evils of pharma or whatever, but I swear that the evil monopoly of printer ink is so much worse, right? Okay, so the idea of a printer is that you take code, something that's on your computer screen that does not exist in the physical world, you send it to your printer and out pops paper, kind of like the physical embodiment of the code. That's right. So every cell in your body, for that matter, every cell in the stalk of celery that you eat, this is what makes life, is a molecule, or this giant molecule called the ribosome. The ribosome is a printer. And so what the printer does is it takes the code, in this case it's mRNA, and what it does is it makes proteins. And so all we are doing when we are giving you this vaccine, we're giving you mRNA. Again, that's a totally natural molecule. Like I said, that is in every stalk of celery that you've ever eaten, right? You are eating mRNA. It's part of everything that's alive. And so we give that code to your body, and it goes into the printer, into the ribosome, and out comes the spike protein of the coronavirus. And then again, that spike protein doesn't make you sick, but what it does is it makes it so that your antibodies recognize it. And so that now the next time they see it, whether it, presumably if it's on a real virus, they'll attack it. And so, so that printer is kind of what we're doing with this new technology is so cool, is that we're just taking advantage of that printer. Like I said, we're sending code into your body, and out's coming the spike protein that we can then fight against.
Awesome. I love that.
It almost sounds like magic.
Mm-hmm.
Oh, it's almost as good, but it's science. It's better, right?
Yeah.
Sorry, I had to get cheesy there.
Well, it's kind of like the magic of a 3D printer. That still boggles my mind how that can actually work.
Well, I'm nerdy enough. We're recording this from my basement, right? I literally have 2 3D printers on the other side of the wall right behind me or whatever that are making stuff or whatever. So yeah, because like I said, I 3D printed that spike protein just when I first, So when scientists first, published the code of the coronavirus proteins, we were then able to just take it, turn that code into a physical thing. And that's literally what your body is doing as well.
Great word pictures, great metaphors. Awesome.
Right. Okay, before we go, Tiffaney, where can folks learn more about your work or connect with you?
Sure. I am at Presbyterian College School of Pharmacy in Clinton, South Carolina, and my contact information is on the school's website. And there is the Wellness Center that I'm coordinator for, and some information about our programs is listed right there. But, I'd love to have anybody reach out that wants to talk with me. Happy to.
Awesome. Brent, what about you? Where can people connect with you?
So again, I don't need to give you a URL, but if you just Google my name, which I'm sure will be in the show notes or something like that, it'll bring you to probably my research group's webpage. You can see lots of nerdy chemistry stuff there. Probably, a couple links down will be the Rate My Professor profile if you want to read funny reviews from students or whatever, right? That's always up. That's in the top 10 hits probably on Google as well. And then I mentioned,
is that little hot pepper still beside your name on Rate My Professor?
No, they don't do that anymore. Which is good, right? Like, there's some.
It used to be there. Just so y'all know, it used to be there.
There's some pretty funny comments, right? You're like, wow, I really said that in class. Who knew, right? And then I guess the other thing I mentioned it earlier is that I'm really interested in kind of the intersection of science and faith. To some extent, I've avoided those topics, right? I don't want to get into like some crazy match on that, but I've started realizing that I need to engage on that more. And so, like I mentioned, I gave a lecture to a whole team of pastors and missionaries not too long ago via Zoom, of course. And so I'm planning to make another web video about kind of faith and the coronavirus vaccine, and just kind of to try to address some of the concerns that are in the faith community. And so I'll post it to YouTube. Maybe by the time this podcast is live, it'll probably be out there as well.
That's awesome. And feel free to share this with your students or pastors and missionaries that you speak to, or any other groups that you speak to. We've got a great conversation recorded here.
Mm-hmm.
So Join us next week. We're still on the topic of health and healing, and next week we'll be talking about self-care and tools for personal mindfulness.
Yes, and we want to thank you both so much, Brenton and Tiffaney, for being with us tonight. This was, I don't know, Holland, I just keep saying this was my favorite. This was my favorite. I don't know how a conversation about vaccination could be one of my favorite conversations, but this was phenomenal. Thank you two so much. As we leave tonight, please make sure you rate us, give us a review on Apple Podcasts or Google Podcasts. Please go to theafterwordpodcast.com because it does help keep the conversations going. We love hearing from you. And as always, you are welcome at our table.